Hello friends, welcome once again in our next lecture or next session. Today we are going to start a very interesting chapter. The name is complex number. Is actually chapter number 5. Chapter number 5 is this complex numbers and quadratic equation. In this chapter we have to learn interesting kind of numbers known as complex numbers. Now you know that what about real number, right? But complex number is what? Let me explain. Suppose we are going to solve one interesting question or one interesting equation. So let us introduce a complex number with help of an equation. Let us solve equation this x square plus 1 is equals to 0. What you get? I think you said that sir is not solvable. Okay, you are right. I just said that if we solve, then I have to write that x square is minus 1. And what about x? I must write x is equals to under root minus 1, which is not possible, right? How can I write x is under root minus 1? It's not possible to write. I know also very well that under root minus 1 is not possible to write. But you can just imagine that. What about the square root of minus 1? But how can I imagine minus 1 square root? Negative value ka square root? I think is not possible in general. Right? So this is not a real number. We said that which is not a real number. I know very well that. This is not a real number. And that's why this number is known as imaginary number. A number which is not real, we may say that is imaginary number. So therefore in mathematics, this square root minus 1 is known as imaginary number. So here, remember that this square root minus 1, a specific number square root minus 1, I write in inverted comma, this square root minus 1 is known as imaginary number. It means we have to imagine this number. So is known as imaginary number. Imaginary number is this. So this kind of imaginary number now let us learn. Okay. But my friend, what the application of this imaginary number in mathematics? Why we are going to solve this kind of number? Why we are interested in this number where we have already 4 different kind of numbers? Set n, set z, set q and set r, right? But my dear friend, the set r, when we derive as cross product, it means that is the related chapter relation and function. So I think if you know, then r cross r is the set of ordered pair. So this kind of ordered pair is also known as the set of complex number. But here our question is this square root minus 1. How we apply this in mathematics? So let us give this number as iota. We say that is iota. Iota means this square root minus 1. Because of that, the first letter of the word imaginary number is also I. So that's why this number let us say as iota. So here I just noted this number as denoted root minus 1 as iota I. So therefore I is under root minus 1. And so we arrived at very important result, that is I square, which is minus 1. I square is minus 1. So I is the number which is square root minus 1 and whose square is minus 1. So it is a really very interesting result, right? So you just easily remember that I square, if you want to calculate, then we will get as minus 1. And so I square is minus 1. It means that one solution of this equation, I repeat once again the question, solution of this equation is what? I just said that I is the solution. What to do? Now let us take two real number. What is complex number? Let us define now. What about complex numbers? Or complex numbers are what? complex number. So let me define. If A and B belongs to R, it means AB are real numbers, then a number A plus IB, see here the number A plus IB, this number A plus IB is said to be, this number is said to be a complex number. This number is complex number, said to be a complex number. So what is complex number? Complex number is actually combination of two real number A and B, where B is multiplying with I, and you know that now I is minus 1. But I just take several examples to understand that. For example in general, 2 plus 3i, I just write 2 plus 3i, 5 minus 7i, that after 4 plus I into minus 2 by 3, you just take any kind of number, A is 4, B is minus 2 by 3. Okay, one more thing, 7 minus 8i, let me write, this all are complex number. Okay, not only that, any natural number is also complex number. See, here is interesting thing, every real number is also complex number. Every real number is complex. Interesting, is complex number. Why? Let me give the reason. Or let us select any real number. Suppose I write 7. Then how can you write 7? You just write that 7 plus I into 0. See here, just a number which can be expressed as the form A plus IB is said to be complex number. जो complex છે ધ્યાન રાખજો, એટલે complex જ વાત જ complex કરવાની છે. 7 is 7 plus I into 0. Suppose you just take minus 3, then what you write? Minus 3 plus I into 0. I into 0, 0 થઈ જાય ને? But now it can be expressed as A plus I. So each and every number which can be expressed as A plus IB is known as complex number. Okay, now complex number itself denoted as small z. Remember that. So remark, I just write one remark. Complex number represents as z equals to A plus IB. Z equals to A plus IB. It means a complex number is denoted as Z equals to A plus IB, right? Where this A is what is actually real part of Z, right? This is real part of Z. Why is real part of Z? Because this first number is not multiplying with any complex number, any imaginary number I. See here, this 7 can be written as 7 plus iota into 0. So that's why this 7 is real part. This minus 3 is real part. And what is B? So B is imaginary part of Z. B is known as imaginary part of Z, my friend. P is known as imaginary part of Z. So that's why each and every complex number can be written as Z equals to A plus IB. A is real part of Z and B is imaginary part of Z. I am Z in short. So this is the representation of both kind of part in the case of complex number, right? Now just we add, subtract. What about the algebra of complex number? Let us explain. So algebra related to complex number, but before that let me clear. If two complex number are equal, then what we say? So second remark, let Z1 equals to A1 plus IB1. It means first complex number is of the form A1 plus IB1, and the second complex number, let us say Z2, is A2 plus IB2. These two complex number are given. So let Z1 is equals to A1 plus IB1 and Z2 is equals to A2 plus IB2 are equal complex number. Then what we say? These are equal complex number. Then we must say that Z1 is equals to Z2, and therefore we just say that A1 plus IB1 is equals to A2 plus IB2. How lakhai? If this both complex number are equal, then we may write that A1 plus IB1 is equals to A2 plus IB2. Now what to do? Now compare real part with real part. From this, we say that from this A1 we may write as A2 and B1 we may write as B2. So આનો meaning શું થાય? The meaning is what? Comparing real part and imaginary part. By comparing real part and imaginary part. તો આ ચેપ્ટરમાં બહુ આવી મજા આવશે. And imaginary part on both side. On both side. That's why I write this. So we may always comparing real and imaginary part in that case. Okay. So these are simple thing related to complex number. Now we have to learn about basic algebra related to complex number. So let us learn algebra to complex numbers. In this algebra we have to learn about addition. Which kind of addition is there? Let us see. First of all, we just add two complex number and let us see what happens. So you know that addition is possible. First of all, first basic algebra is this: if Z1 and Z2 belongs to C. Okay, C is what? C is actually the set of all complex number. C is the set of all complex number. It means every complex number taken from set Z. Set of all complex number. જેમ કેમ તમે real number નો set બોલો છો ને, capital R. Similarly, set C is the set of all complex number. So if Z1, Z2 belongs to C, then first of all the result is this: Z1 plus Z2 belongs to C. એનો meaning શું થાય? If two complex number are given, then addition of two complex number is also complex number. Subtraction is also complex number. It's very obvious. Second thing, Z1 plus Z2 can be written as Z2 plus Z1 clearly. There is no issue about it. Third one, 0 is itself a complex number. Right, 0 is complex number, but before that I just take Z1 plus Z2 plus Z3 can be written as Z1 plus Z2 plus Z3. Okay, do you know that which the rule is this? This is actually Z1 plus Z2 is Z2 plus Z2 is actually commutative law. I think you know that. This is commutative law. And what about this? This is associative law. Associative law, right? That after the third thing, fourth thing, 0 is any complex number. I think you know that. A complex number 0 which is represented as 0 plus iz. A complex number 0 equals to. How can we write 0? I can write 0 as 0 plus I into 0. A complex number 0 is said to be identity. identity for addition. Now identity is what? You know that. Identity means this 0 you add in complex number, then there is no effect. So therefore z plus 0 is z is 0 plus z. This is very obvious. 0 is here complex number, remember that. Fifth thing, for every complex number, z equals to a plus ib. For every complex number, z equals to a plus ib. There exists a number minus z is equals to minus a minus ib, right? Such that I just write that z plus minus z is 0 and is minus z plus z. ये तो तुमने आम भी खबर है ना. For any real number also 5 minus 5 is 0. So the same kind of thing is there. Z plus minus z is 0. So here this minus z, here minus z is what? Minus z is what? Is actually additive inverse. So minus z is additive inverse. Remember that is known as additive inverse. Is additive inverse of z. So these are properties related to addition. In the next lecture now we will discuss about property related to multiplication. Okay? Thank you very much.